Hey, guess what time it is, class? It's science time. Now take out your notes and let's get learning. Hey, class, how's it going? Well, I apologize that I was not able to get this out a little bit sooner. I had some technical difficulties with one of the other videos from one of the other classes. And after making several recordings, and then the last one was really good, and then I realized I forgot to hit record. Yeah, that was fun. So I apologize for the delay, but don't worry, we're going to have some fun here. So, what we're going to be doing is doing the activity Aim for Your Grade. And some of you may have heard about this. This is just a variation from the Shoot for Your Grade that normally we would have been doing. This is the one where you have a ball rolling down the incline and it lands on a piece of carbon paper, which puts a little mark on another piece of paper, and you can mark where exactly does it land, and then you'll move the ramp and the ball to a different elevation, and then that's when you put a target and a loop for it to go through. So we're going to do a little bit of a variation of this, and I had some assistance with my son in setting this up, and he was very, very excited about doing this. This is Mr. Souder, and I have my son here helping me, and we're going to do an experiment. So what he's going to do is he's going to release a car on a ramp, and it's going to land on a piece of foam, and we're going to mark where does it land. So go ahead and release it. Go ahead.
Wow, that's farther than a meter. Okay.
So you can see we've done this several times, and we're getting a good cluster.
Okay, so
Points here.
I have an idea.
Go. So this is the basic setup. We have a Hot Wheels car, and we have a little Hot Wheels track making a little ramp going down here. There's a little line on the track that's going to be the starting line, and the Hot Wheels goes flying off, and then it ends up landing on the ground. And I put a little piece of foam down here so when it lands, it puts a little dent in the foam. And by measuring this distance, we're able to determine how far out it had traveled. So, two bits of information that is important for this is what is the range. Basically, that is the distance in the x direction, and how high was the ramp above the table, or I'm sorry, above the floor. So we're looking at the height, or which is the distance in the y direction. So from the test, these were the measurements that were taken, and the horizontal range was about 0.545 meters, and the height of the ramp above the floor, or actually above the piece of foam, was 0.655 meters, as you can see here. So here is a data table to assist you. And so we have the information broken down as the givens in the x direction and the givens in the y direction. So you're looking at the distance in the x direction. This distance here was 0.545 meters. In the y direction, the height was 0.655 meters. The acceleration horizontally, there is no horizontal acceleration. And in other words, if you remember, with any type of projectile, once it leaves the surface here, it will always maintain a constant horizontal velocity. Now, while it's going down here, the horizontal velocity is changing here, but once it leaves the table, once it becomes a projectile, this horizontal velocity remains the same, pointing in the same direction, again ignoring wind resistance. Now, in the y direction, it's a little bit different. In the y direction, you're only looking in this direction here. When it first leaves the table, it's leaving the table horizontally. It has no vertical velocity. So it's acting as though if you just took this car right from the edge of the table and just dropped it straight down. So initially, it's dropping from rest, or 0 meters per second. The final velocity here for the x direction is going to, again, maintain a constant velocity all the way down. So the velocity here is going to be the same velocity here because there is no change in velocity. Now, because it's going horizontally, I'm sorry, it's also going vertically, then since it's being dropped, initially it has no velocity, but it's going to speed up, speed up, speed up, speed up as it goes down, and it's going to have a higher velocity the moment before it hits the ground. So that's one thing, that's one reason why I have this area blank here, because you'll need to figure this out. And then also time. Well, the one thing that's going to determine how much time it spends in the air is not the horizontal vector, it's the vertical vectors here. So using the information that's over here, find out the time that it takes for it to drop from the edge of the table to the ground. Once you have that time is also the time for it to travel horizontally. And once you have the distance and the time, you can then solve for the velocity using this equation here. So here are the equations that you need for the y direction. Here are the equations that you need for the x direction. So use this information and use these formulas to solve for these two. Once you have the time, you can then, that's going to be the same time over here, and using the time and the distance, solve for the horizontal velocity. So that's going to be your first homework assignment, is to solve for Vx, V sub x. Now, let me give you an idea what this lab is going to be leading up to. So again, once you solve for Vx, later on, I'm going to give you some additional information. And what's going to happen is we're going to take the exact same setup and we're going to raise it up. Isn't that cool animation? It's like, I know, Mr. Souder, you should be working for Pixar. I know, really. So anyway, since I'm going to raise this ramp up to a higher elevation. Now it's going to be the same ramp released at the same location, but it's just going to be higher up from the ground. And because of this, because it went up higher and it's still going to be following a parabolic curve, it's going to be landing in a different direction. It was originally landing here, but because we now raised it up, it should now be able to land further out. So the range of it should be increasing. Now later on, I'll give you how high is the table raised up. I don't know exactly how high I'm going to raise it up here, so eventually I'm going to have to give you this information here. But knowing its horizontal velocity and knowing this height, you should be able to tell me what is the range, where would this Hot Wheels car land. So you're going to ultimately give me what is the range of d sub x. So what is this new landing location? So what I should be able to do is raise up to a certain elevation, give you this value, and you should be able to tell me where will this land. And I should be able to put a target down here for it to land on or land inside of, and it should land exactly in that spot. So that's what you're going to be doing. But wait, there's more. I know, this is exciting, isn't it? I know. So one thing you're also going to do here too is that if you know what it is to range from the edge of the table to where it's going to be landing, also what you're going to have to figure out is half that distance. Okay, so whatever distance this is, you're going to take that distance and cut it in half, so you're going to have half its range. And this is where we're going to be placing a hoop. So that will give you the horizontal displacement of where we're going to have to place the hoop. But we want this car to be traveling through this hoop. So the other thing you will need to figure out is where do we have to raise this hoop up to. Amazing graphics, huh? This is exciting. So you'll figure out what is the horizontal displacement, and based upon that, some of that information, you should be able to figure out how far would this have dropped. Now, if you know how far above this setup is from the floor, and if you can figure out how far will this drop, you can then tell me how high do I have to bring this hoop up to in order for this to pass through the hoop. Now there's a problem, and especially for those who play basketball or something like that, it might be pretty familiar here, is that if you end up having a projectile trying to go through a hoop, and you want to try to maximize the amount of clearance for that, this projectile should be going through the hoop perpendicular. So guess what we get to do? we also have to figure out what angle do we have to aim this hoop. Because this way, at this point in time, this projectile is going to have a certain vector. Let me draw this out here. So at this point right here, this is going to have a certain vector, a resulting vector here. We want this to be perpendicular to the rim of this hoop, so that way it's able to more effectively travel through that hoop. Isn't that fun? I know this is exciting here. I enjoy this type of stuff here. So, no, I'm not trying to torture you guys here. This is trying to be fun here. So, I know you guys can do this. So, just to kind of recap here. So again, ultimately, you're going to be taking this information, or actually taking this information here, using these values, and all you have to do for now is just figure out v sub x. Okay, that's all you need to do for now. And then, ultimately, we're going to raise this up, find out what is this new location that's going to be landing, where we have to place the ring, how high do we have to place the ring, and also what angle would we have to place the ring. Okay, so I'll give you the date as to when I want this information here. So all I have to do is just figure out this information that's in this chart based upon this information here. Okay, if you have any questions, please let me know. I hope all of you are doing well, and if you have any questions or concerns, feel free to let me know. You guys take care. Bye-bye.